Thank you so much for the opportunity to spend some time with you this morning. I'm going to start out by talking about this. Does anybody know what that is up on the screen? iPod, right? Everybody knows that's an iPod. And that's not just any iPod. That is my iPod. That is my original iPod. I bought that in the year 2004. And it had 7,250 songs on it. I even had that little thing you could plug into the top, that radio frequency thing that would play the songs on the radio. Remember that thing? So that was technology. That was technology 15 years ago. What else could that do besides play songs? Nothing, right? That was it. Now think about all the things. Every one of us walks around with an iPhone or some version of a smartphone, and think about all the things that that phone has replaced. Cameras, calculators, levelers, compasses, gaming controllers, credit card scanners. We're not done. Video players, wristwatches, timers, books, photo albums, Rolodex, all these things that we used to have to carry around with us if we wanted to use them, we can now use our smartphone for. It's amazing how far technology has come in the last 15 years, not just in the world of communications, but in the world of manufacturing technology. Think about the times that we live in. In 1 minute, every single minute in technology, we have 1 million Facebook logins. 18.1 million text messages are sent, 4.5 million videos are viewed, 390,000 apps are downloaded, 87,500 tweets take place, 1.4 million Tinder swipes every single minute, God help all of us, 188 million emails, 180 smart speakers are shipped by Amazon every single minute, 41.6 million instant messages are sent, 694,000 hours of Netflix videos are watched every single minute, 3.8 million Google searches take place, 300 hours of video are uploaded to YouTube every minute. And in the 1 minute it took me to go through that slide, we spent $1 million online. That is the world we're living in. And it is affecting not just the world of general technology, but it is changing manufacturing at warp speed. Would you believe that right now today, General Motors has 15,000 robots that they have loaded up with smart sensors and smart devices, gathering data in real time on things like torque and temperature and humidity and viscosity and moisture, sending that to the computer network, sending that to a data collector, sending it up to the cloud, where an analytic is measuring all of that information coming from all those robots. Right now today, GM has those robots to the point where they can predict their own future failure and order their own replacement parts before the failure ever happens. And that is the world of manufacturing technology that we live in. This is being driven by what we call the fourth industrial revolution. Now, every Industry 4.0 speaker has their Industry 4.0 slide. This one is mine. The idea is that we go back to the 1700s, and we had mechanization and steam power that revolutionized manufacturing. Late 1800s, early 1900s, same thing happened when we had electricity and mass production. Then we go to the late 1970s, early 1980s, with computers and robotics, and that revolutionized manufacturing. And the whole idea is that today we are on the verge of the fourth industrial revolution, where technologies like cyber-physical systems and machine learning, artificial intelligence, digital twins are transforming the world of manufacturing in the same way that these old technologies transformed it years and years ago. Now, I first got fascinated by this technology on a trip to Japan. It was about 5 years ago. And I went into this manufacturing facility at the base of Mount Fuji, 21 million square foot manufacturing campus. And we walked into a building, it was 300,000 square feet, and they had these gigantic machining centers. So gigantic machining centers that were machining parts, about fit 2 or 3 of those in this room, all of them being fed by autonomous vehicles that were driving all over the facility, handing material to a robot. The robot would put the material into the machining center. The machining center would give it back to the robot. Robot would give it back to the AGV. AGV would take it to the next operation. It was absolutely fascinating. It was a 300,000 square foot facility running 24 hours a day, 5 days a week, with 12 people. And it was at that point in time, about 5 years ago, as I said, that I realized that manufacturing technology was going to change forever. I was a manufacturing CEO for 23 years before acquiring Lab Midwest, the company that Scott shared with you a little while ago. And I knew at that point in time that manufacturing would never be the same. And then they took us about a half a mile away. It could have been half a world away. They had this huge screen with all of these icons, with all of these machining centers, all these robots, and they pressed one of those icons on the screen, and it gave us all the data we would want to have. What is the cycle time? How is it performing to its standard? When was the last time it was maintained? When was the next time it was supposed to be maintained? And then while we were standing there, one of those icons turned red. And the gentleman giving the presentation pressed it, and a screen came up, and it showed that there was a line down, and it showed how much production had been lost. And it showed the suspected root cause. And as we stood there, a video came up and showed one of those 12 people responding to that line down situation. Absolutely blew me away, and that started this total fascination with Industry 4.0 and IIoT. I write the monthly leadership columns for Production Machining Magazine, Products Finishing Magazine. I've been writing those for 15, 16 years now. Every single month I have to come up with a new topic. I've written about this extensively. About 4 years ago, we wrote a white paper on how we drive Industry 4.0 learning and IIoT in the world of education, how we prepare students and learners for this next world. That was basically picked up by the M7, the 7-county regional economic development engine here in southeastern Wisconsin, as the platform for how we prepare students and learners for Industry 4.0 technology and careers. This white paper, by the way, has been adopted as far away as Saudi Arabia as they look to figure out how they're going to morph their economy from an oil economy to a technology economy. So we're really, really proud of that, and that led to this concept of what we call Infinity 0.0, which I use somewhat interchangeably with Industry 4.0, the whole idea in my mind that there won't be an Industry 5.0. There won't be a fifth industrial revolution. We are on a verge and in the middle of continuous development, continuous innovation, continuous evolution in the world of manufacturing technology. And it's up to all of us to figure out a way to keep up. So before we talk about some of the ways that the state of Wisconsin is leading in Industry 4.0, and believe it or not, we are, and we'll talk about how we're leading in Industry 4.0. I want to talk about some of the core technologies, not all of them, but a handful of the ones that fascinate me in this whole world of Industry 4.0 technology. First one is smart sensors and smart devices. Every one of you walked in with one of those this morning. What is it? Smartphone? Right, exactly. Those are smart sensors and smart devices, in that case, smart devices. So it's the same technology, by the way, that some people's refrigerators use to know what's in them, how long it's been in there, when it's going to go bad. They'll even make your grocery list for you, believe it or not. And that smart cities use to track everything from emergency services to energy and everything in between. So that is what we mean by a smart sensor or a smart device. So two things, this is important, two things that differentiate smart devices and smart sensors from their predecessors. Number one is they have the ability to communicate with other smart sensors and devices. So they can communicate on their own without having to go through a computer network. Number two is they have embedded intelligence. They can make their own decisions. And what you see in the middle there is a whole list of the types of smart sensors that we see being deployed in the world of manufacturing. So smart sensors live out on the edge. When you hear edge devices or edge computing, we're talking about smartphones, smart sensors, and smart devices out on the edge, not to be confused with the fog, which is our computer networks, our data collectors, our PLCs in manufacturing, or for that matter, the cloud, which are the external data centers where a lot of this data is stored and processed. So here's what's happening in the world of manufacturing. This is why this is fascinating. I grew up in a world of Industry 3.0. We had a sensor that would gather data. It would send it to a computer we call the programmable logic controller. That programmable logic controller would make a decision with what it was getting from the sensor and would send that decision to an output device. I have a processing tank that's too warm. I need to cool it off. The temperature sensor recognizes it, sends that information to the PLC. PLC says we need to activate a cooling coil to cool that tank down. That's the world that I lived in. The challenge with this technology is two things. Number one is it takes time for all of that information to move across the network in a manufacturing plant, what people in that business call latency. It takes time, sometimes only microseconds, but it takes time. Number two, it takes up a tremendous amount of bandwidth. And because of these two constraints, we basically limited the number of smart sensors and devices, or sensors and devices that we could use in the world of Industry 3.0. Now what happens when we make these things smart so they can make decisions? Now what happens when they can communicate with other sensors and devices? Our need to communicate with the PLC goes away, and we can deploy way, way more of these in manufacturing, and that is exactly what's happening. So about a year and a half ago, I was sitting in the lobby of Rockwell Automation. I was waiting for a meeting, and in walks a guy named John Carrier, fascinating guy. He's with the Sloan School at MIT, Industry 4.0 expert. And what I love about him is that he's an academic, but he lived in the world of manufacturing for 20 years, so he walks the walk as well. So he knew that I ran a private equity-backed manufacturing company for a bunch of years. He was fascinated by that model. We talked about that. And then we got to talk about smart technology. And here's what John said. He said the size of smart devices and smart sensors is decreasing. They're getting smaller and smaller so we can put them more places. He said second, they are coming down in cost by orders of magnitude. Order of magnitude means something that was $1,000 becomes 100, 100 becomes 10, and that is exactly what's happening in manufacturing. He said right now the cost to deploy a smart sensor or a smart device in manufacturing is less than $100. So when we talk about how we transform manufacturing, it literally is one sensor at a time. It is one decision. It is one $100 investment at a time. We don't have to transform an entire manufacturing plant. Let me give you a little bit more on this whole idea of smart technology. About a year and a half ago, Mark Money, who's the chancellor at UWM, very good friend of mine, called and said, hey, I'm having a cocktail party for Brad Smith. Would you be interested in joining me? And I said, cocktails? Heck yeah. Who's Brad Smith? And I didn't know this at the time. Brad Smith is the president of Microsoft. President of Microsoft, and he actually is a Wisconsin native. He grew up in Appleton. Really, really nice guy, fascinating guy. Midwest nice, if you know what that means. And so got the opportunity to spend some time with Brad Smith. Here's what he said. He said by 2025, this whole smart technology, this whole number of devices that are deployed on the internet will be 75 billion with a B. They think it's a $2.7 trillion market annually. You think that that is a market that Microsoft is thinking about. And of course it is. So if there's any question about whether smart technology will transform our entire economy, including and especially manufacturing, we should put that question to bed because it already is transforming manufacturing. We have smart RFID, we have smart photoelectric sensors, we have smart vacuum sensors, we have smart barcode readers. All of these are smart, communicating with other sensors and devices, just taking the pertinent data and sending it onto a PLC or sending it on to a data collector. And this is revolutionizing the world of manufacturing. Let's talk for a minute about informationable data in Industry Infinity 0.0 careers. So in my Industry 3.0 world, if we had a problem on the manufacturing floor, we would get a group of managers, a group of supervisors, and we would go out on the shop floor and we would stand around the problem and we would look at it and we would talk about it. And it wasn't long before we realized that none of us had anywhere near enough data to make a decision and try and fix the problem. So we would find somebody we called an industrial engineer, we would hand them a blank piece of paper on a clipboard, and we would say, stand out there with a stopwatch and track data for a day, a week, a month, whatever it took before we had enough information to be able to make a decision. And that was the world that I lived in. Folks, in the world of Industry 4.0, in the world of Infinity 0.0, our problem will not be a lack of data, but way, way too much of it. Would you believe that most companies only analyze about 12% of the data that's available to them, leaving the other 88% to go to waste? The amount of data generated every second in the financial industry is said to grow 700% this year. The big data analytics market is approaching $103 billion and will be there by the year 2023. Using big data, I think this is fascinating. Using big data, Netflix saves $1 billion a year in customer retention by watching what you watch, when you watch it, when you turn it on, when you turn it off, and delivering content to you that they know you will find interesting. $1 billion a year. And the amount of data created over the next 3 years will be more than that created in the last 30 years combined. We are swimming in tremendous amounts of data. What is a quant? Anybody know that name? They have these people on Wall Street. They're financial analysts, quantitative analysts. It's a person who analyzes a situation or event, especially in a financial market, by means of complex mathematical and statistical modeling. There's even a school for these people called the Stevens Institute of Technology in Hoboken in New Jersey. Now, I was reading an article in Forbes magazine not too long ago, and here's what this young man, 22-year-old guy named Dakota Wixom said. He said, you can't just buy growth stocks anymore and expect them to outperform the market. It becomes a data science problem. There are hundreds of hedge funds out there, and only a handful of them achieve alpha every year. What he means by that is only a handful of them beat their market averages every year. How do they do that? They hire quants, they hire data scientists, and they hire programmers. And that's why I'm a huge believer that if you or someone you know is smart, analytic, and career undecided, there is a huge opportunity for them in the world of data science, in the world of data management, data analytics in manufacturing. This is the analysis of the future. Excuse me. All right, let's talk about Infinity 0.0 careers. What all of this technology is doing is totally changing the world of work in ways that are going to blow us away in the next 5 to 10 years. About a year and a half ago, Manpower released a study, and they went through a whole list of the types of careers that are going to exist in the world of advanced manufacturing and Industry 4.0. Look at these titles: Chief Digital Officer, Manufacturing Analytics Scientist, Digital Manufacturing Systems Architect, Collaborative Robotics Specialist, Automated Guided Vehicle Systems Engineer. These are the type of jobs that are going to exist in manufacturing in the very, very near future. It's absolutely fascinating. Would you believe that automation engineer is the fourth happiest job in America, according to USA Today? Fourth happiest job in America. How many young people even know that that is a job that they could have? We're going to talk about that later, but as you see these young people competing in this team robotics competition, and credit to my good friend Jay Partington for his vision in putting this together 2 years ago, you're going to see what the world of work in the future looks like, and you're going to see students that are preparing themselves for that world of work. And by the way, this technology isn't just affecting manufacturing, it is affecting every single corner of our economy. Students selecting that career pathway are not precluding all the other ones. They're preparing themselves for a huge number of different jobs. All right, now let's talk about digital twins. So I just find this technology fascinating as well. For a bunch of years, I was responsible for the company. We actually sold it in 2015. The company that built all of the fixtures for Harley-Davidson for all their paint lines. So whether they were painting a fuel tank, they were painting a swing arm, they were painting a fairing, they were painting a frame, all of those items were fixtured on fixtures that our company called American Finishing Resources designed, engineered, and fabricated for them. So I'm fascinated by this world of painting motorcycles and especially painting fuel tanks. So that's why this display caught my eye not too long ago. Obviously it's a paint robot painting, actually simulating the painting of a Harley-Davidson fuel tank. So I was fascinated by this display. I'm watching it, and there's an engineer that put it together that walks up to me and taps me on the shoulder, and he said, "What are you looking at?" And I explained to him why I was interested. He said, "If you think that's cool, check this out." And he took me across the hall into a room, and they had a computer screen in there that was running an exact digital twin of what was happening on the manufacturing platform. Digital twinning is going to completely revolutionize innovation in the world of manufacturing, and let's talk about why. Would you believe that NASA actually has an advanced manufacturing program? NASA does. It's called their SATOP program. I actually partnered with them several years ago to develop a material handling solution for, at that time, all 4 Harley-Davidson plants, moving material all over their facilities. And we were literally able to go to the customer and say that our solution had been developed in partnership with NASA. It was. We applied for a grant, got a grant to co-develop the solution with them, with NASA. So there's a guy by the name of John Vickers who runs their advanced manufacturing program. Here's what John Vickers says about the digital twin. He said the ultimate vision is to create, test, and build equipment in a virtual environment. And not until we have that equipment working exactly the way that we want it to virtually do we build the physical manifestation of that equipment on the shop floor. And then once we have that equipment done, we load it up with smart sensors and smart devices, gathering data in real time, and over time the digital twin gets smarter and smarter and smarter. Here's why this matters. What is, and I've lived this world, what is the scariest day in the life of an industrial engineer? What is the scariest day in the life of a manufacturing engineer? It's when you make a change to the process, right? It's the day that you say, you know what, we're doing this well, but we think we could do it better. And there's a customer on the end that is going to scream bloody murder if the parts aren't right, if they're not perfect, if they're not on time. That is the scariest day in the world of manufacturing innovation. Because if it works, you're a superstar, and if it doesn't, it's a total disaster. So now what happens when we load these manufacturing lines up with smart sensors and smart devices, and we connect them to a digital twin that gets smarter and smarter and smarter in mimicking what actually happens on the shop floor. And then when we want to innovate the process, we don't go to the shop floor and innovate the process, we go to the digital twin. And we try things, and we make changes, and we see what happens digitally and virtually before we ever go to the shop floor and do it. How much braver will we be in innovating manufacturing when the day comes that we're not going to be hung from a stick if we don't get the thing exactly right and the customer doesn't get their parts. Absolutely going to totally transform the world of innovation in the world of manufacturing. So now let's have some fun with artificial intelligence. AI is really cool stuff. So Sundar Pichai, who is the CEO of Google, now Alphabet, says this is the most profound thing that humanity has ever worked on. Most important thing we've ever worked on, more profound than electricity or fire. I mean, more profound than a caveman figuring out how to ward away the saber-toothed tiger with fire. Are you kidding me? He's saying it's more profound than the way that electricity transformed manufacturing at the end of the 1800s with the mass production line and everything that came along with it. More profound than either one of those. And by the way, if this stuff fascinates you, I use him as the topic of my podcast. I think it's next week, the Tech Ed podcast. And we're talking all about artificial intelligence in manufacturing. And we use this whole topic as the launching off point for that topic. So artificial intelligence. What is artificial intelligence? This is my friend Murtaza Bora. He is an expert at a company called Quant in Markham, Canada. And he defines artificial intelligence better than anybody I've ever heard. He said, we have to first define intelligence. What is intelligence? He said it's a combination of our experiences as we go through life, where we were born, where we lived, things that we did with our family, where we went to school, and connecting all those things, and connecting and linking ideas, along with our process of learning, which is basically how we increase our own knowledge. And he says if we define intelligence as that, experience and learning, then all we have to do is figure out what do we mean by artificial. So artificial intelligence is just a mathematical representation and algorithmic implementation of intelligence. There's that word algorithm. That made me sick to my stomach in calculus. But algorithm is really easy for our purposes. It's just a list of instructions and rules that a computer uses to perform a task. So artificial intelligence is really just a mathematical and algorithmic implementation of human experience and human learning. That's all it is. When we talk about industrial artificial intelligence, which is pertinent to our group here, there's a really, really good book, by the way, by Jay Lee, who's the vice chairman of Foxconn and responsible for Foxconn Wisconsin. It's not a book you're going to light a fire in the fireplace and have a glass of wine. It's a textbook, but it's fascinating stuff. And he says that basically industrial AI is our combination of, and you guys, this will be familiar to everybody, it's analytics. So how are we going to process data? How are we going to analyze data? Huge data sets, more data in the next 3 years than in the last 30. We talked about that already. Computational platform, we already talked about edge devices and networks and the cloud. So it's the computational platform. Domain knowledge, which is your understanding of your CNC machines, your robotic weld cells, your conveyors, whatever it is that you do in the world of manufacturing. The evidence and the information that those machines are feeding to you about what happens when you make changes, and how we create a feedback loop. How do we go back and create standard operating procedures so that as we're learning and as we're using AI as a tool to learn from our manufacturing processes, that we can use that for continuous improvement, which in the end should be what Industry Infinity 0.0, Industry 4.0, and artificial intelligence in manufacturing is all about. So let me ask you this. What is opinion size, age, shape, color, origin, material purpose? That is the order in which you, without even knowing you're doing it, place adjectives before a noun. Which is why if I say lovely little old rectangular green French silver whittling knife, I sound kind of weird, but you can picture exactly what that might be. But if I use the same adjectives and say old little French whittling lovely silver rectangular green knife, I sound like I'm nuts. You do that without even knowing that you're doing it. That's why we can't say my big Greek fat wedding or my walking leather brown boots or green little men. We say little green men. How about IAO? Anybody know what that is? That's the order in which you, without even knowing it, will place similar sounding words according to their vowels. Which is why it's really hard for me to say mash, mish, chat, chit, dally, dilly, shally, shilly, top, tip, hop, hip, flop, flip, tack, tick, and dong ding. But I can say mish, mash, chit, chat, dilly, dally, shilly, shally, tip, top, hip, hop, flip, flop, tick, tack, and ding dong really fast. We don't even know that we do that. That's a rule of grammar that we use that we don't even know we're doing it. So when you think about how weird our thought processes are, you get a feeling for how much of a challenge we're putting in front of data scientists when they try to make machines think like people, but they are making progress. I saw this webinar. I think I saw it on YouTube. It was an interview of Elon Musk about 2 weeks ago. He said that in 10 years, we won't be able to buy a car that doesn't drive itself. Not only will self-driving cars be ubiquitous, according to Elon Musk, but we won't even be able to buy a car that doesn't drive itself in 10 years. He said Tesla already has enough smart devices and smart sensors on a Tesla vehicle that he believes it can drive itself safely, more safely than a human being can drive it. He said it's just a question of letting all the software and the social norms catch up with the hardware that's on his cars. Now, I don't know if he's right, but I thought he was crazy 10 years ago when he said he could launch a rocket into space and then land it back on a platform. He managed to figure that out. Who knows what's coming? About a month or so ago on my podcast, I had Chris Dries. Chris is the president of Mercury Marine. And we had a whole conversation. Brilliant guy, came up on the manufacturing side. He's now the president. I love people in leadership roles in big companies that understand manufacturing. Chris is one of those people. And we had this whole conversation around smart technology manufacturing. A bunch of great examples. You can go back and listen to that. But one of the things that he said was that they are on the verge of creating boats that will pull themselves into the dock on their own. Now, I'm a lifelong sailor, I'm a lifelong boater, and I can tell you that there were a lot of people on my dock in McKinley Marina that would have benefited from that technology because we saw a lot of boats run into docks. But we're on the verge of having boats that can dock themselves. Who knows who Waymo is? We've got one in the back, Google's self-driving car company, right? So I started tracking these guys about 5 years ago when they had gotten to I forget what the number was, 4 million self-driven miles with their cars, and then the number was 7, then it was 8 million, then it was a year ago, it was 20 million miles that these cars have driven themselves. Then we had COVID, and they simulated all these driving miles, 100 miles of driving per day, 100 years of driving per day, even while working from home. So that's what Google is doing with their self-driving cars. Here's why this is important, and here's why it's important for us in manufacturing. Let's assume that you and I are sitting in a Google car in California. It's driving itself around on the road, and it's sending information up to the cloud. What is a mailbox? What is a person? Where people are likely to cross the street? Where other cars are? Where the traffic is? Sending all this stuff up in real time. And then taking all that information and sending it down to every single other Google car that is driving everybody else around. But it gets better. All of the information from all those cars, where's the mailbox, where's the person, all this other stuff gets loaded back up to the cloud, and it comes back down to our Google car. Literally, our car now is as smart as every single other car put together and has as much driving experience as every other car put together. What happens in manufacturing when our robots are smart as all the robots put together? When our CNC machines are as smart as all of the robots put together, where our robotic welders are as smart as all of the robotic welders put together. That is the world we are entering. It's not just about what our machine is doing in our manufacturing facility, but it's gathering data from all the other machines and learning about what's going to happen, what's going to affect a crash, what's going to create downtime. And the companies that are figuring this out, for obvious reasons, are going to end up way ahead of the companies who don't. By the way, we're launching this really cool platform. This is with a middle school in the Oakland School District in suburban Detroit. Middle schoolers, 23 middle schools altogether, teaching autonomous vehicle technology. That same stuff with the Google car, speaking to the cloud, avoiding collisions, really, really cool stuff. And we're working on that, like I said, with a middle school in Detroit. We had this thing set up in our tech center in Mequon on Friday, and our whole team was, everybody was going to leave. It's Friday afternoon, weather's nice. Nobody left at 2 o'clock. They all stayed until 5 o'clock and played around with that thing. It's pretty cool stuff. All right. So we could go on. There's all kinds of other technologies that I'm fascinated by and you're fascinated by in the world of advanced manufacturing. But I want to change gears now in the 10 minutes or so that we have left before we turn it over to you for questions and talk about 10 ways that the state of Wisconsin is leading in Industry 4.0. And I will tell you that in so many ways, we are not as a state giving ourselves enough credit for all the amazing things that are happening right here in our own backyard. So 10 ways that Wisconsin is leading on Industry 4.0. Number 10 is our four-year universities, our research universities, our PhD programs are doing amazing stuff in this space. I think it's later today, it might be tomorrow that, there she is. Do you know when they're presenting the CSI? Is it later today? Okay, awesome. Awesome. Jennifer Abley from UWM, 2 o'clock over at the other stage. So CSI is going to be here, Connected Systems Institute. She just showed up at exactly the perfect time. Connected Systems Institute, doing amazing things in Industry 4.0 technology and connected systems. University of Wisconsin-Madison launched their data science program about 2 years ago. My daughter, who's a sophomore, is actually in that program. When we talk about encouraging young people to get involved in advanced manufacturing technology and data analytics, that's the pathway that she is on. Really, really cool things happening at UWM, amazing stuff happening with Marquette and UWM put together with the Data Science Institute at Northwestern Mutual, and also awesome stuff happening in computer science and MSOE. We are leading here, and there's great stuff happening at Stout and at UW-Platteville and elsewhere. We are leading here in the state of Wisconsin at the 4-year and beyond, the research university level, doing some really, really cool stuff. If you're not connected with these programs, it's time to consider doing that. Number 2, our state is ahead of every other state in the country at preparing students and learners for Industry 4.0 pathways. We're talking about base mechatronics, industrial control systems, industrial robot programming and operation, and the industrial Internet of Things, IIoT, smart sensors, smart devices, data analytics. Students all over the state in one of those 4 courses learning about advanced manufacturing technology. And I'm going to tell you that is important for 2 reasons. The first one is we need that talent, right? The second one is the number 1 influencer of a young person's career pathway. And everybody says, well, it's your parents, it's your career advisor at school, it's social media. Number 1 influencer of a young person's career pathway, according to a study done by the Manufacturing Institute and Skills USA, and it isn't even close, 3 times greater than any other influencer, is a young person's interests and experiences when they're in middle school and high school. And so we say if your tech ed programs in your high schools don't look like that, that's why you can't find people in manufacturing. As you watch these young people competing in this robot challenge right outside this door, you're going to see what is possible in the world of high schools, and it is fascinating. Number 8, we in the state of Wisconsin have trained 342 instructors and teachers to bring the kind of technology that we talked about this morning back into the classroom in a 40-hour course designed to prepare them to understand this technology. And it's a lot of tech ed teachers, but I can tell you it's a lot of science teachers, it's a lot of math teachers, it's a lot of physics teachers, because that is the way we are going to drive this through our high schools. 342 instructors that have been trained. And by the company that does this, which I have a very close tie to, does it for free. It does it for free for their customers, it does it for free for their prospects, and it does it for free for people who will never buy anything from them because they're a mission-driven company and they feel it's really, really important to get these students and these instructors and teachers into the classroom understanding these competencies. Number 7, our industrial employers here in the state of Wisconsin are absolutely leading on training their incumbent workforces in Industry 4.0. So if we think about how we prepare our students and learners for these careers, that's really, really important. But 10, 15 years ago, from now, 10 to 15 years from now, the vast majority of your workforce will be people who already work for you today. And so we can make all the investments we want in our high schools and our technical colleges, and we have to. The only way that we ever solve the shortage of skills talent here in the state of Wisconsin and across the country is by employers taking their responsibility to train their own workforce. 1970s, average industrial employee, 100 hours a year of skills-based training provided by their employer at the worksite. And today that number is 5 hours a year, and it's lockout, tagout, bloodborne pathogens, confined space entry, all the things that OSHA tells us we have to train. But I can tell you here in the state of Wisconsin, 12 of the 15 largest companies in this state have incumbent worker training programs around Industry 4.0. And if you're in the world of manufacturing and you're not training your incumbent workers on that same technology, you're missing a huge opportunity. Number 6, Foxconn gets a little bit of a bad rap, and I'm not here to be a huge advocate or not be a huge advocate. Everybody can make their own decisions. I will tell you that what is happening at Foxconn AI downtown is unbelievable. And now they're moving some of that down to Pleasant Prairie as well. But in as much as the scope of what was going to happen with Foxconn has changed, pay attention to what they are doing in artificial intelligence. They are employing, this is actually a picture of several of their student interns from this summer. They're employing tons of people. You drive through Racine, Wisconsin, you'll see big billboards. Foxconn is trying to fill its plant and fill its AI program. with individuals. But I referenced just a little while ago that book by Jay Lee, Vice Chairman of Foxconn. He works here in Wisconsin. He heads up their AI program. And so they're getting probably not getting quite as much credit as they deserve for what's happening in the world of artificial intelligence. We talked about the labs at Gateway Technical College in my last presentation, if you were in there. Gateway Technical College is in Kenosha, Walworth, and Racine counties. That's their district that they serve. About 4 years ago, their president and CEO, a gentleman by the name of Brian Albrecht, and I traveled the globe. Spent time in Tokyo, we spent time in suburban Detroit, we spent time in Louisville, looking at best practices in Industry 4.0 education. And I will tell you that bar none, what they opened up there about 2 years ago is the most advanced Industry 4.0 learning center anywhere in the world. Anywhere in the world. David Aguirre, and he's going to be presenting later this week from the IIoT Council. There we go. We good? Yes. If you have an opportunity to check out David's presentation, the guy is unbelievable, and he runs the labs down at Gateway Technical College. But what Gateway is doing in the world of Industry 4.0 and other technical and community colleges are either following or helping to lead. I don't mean to single out Gateway, but that is a huge gem that we have right here in southeastern Wisconsin. Number 4, our industrial employers, especially the big ones, are making huge investments in Industry 4.0 technology. So these are just a few examples from our podcast this year. We talked about Chris Drees already, the things he's doing at Mercury Marine, Austin Ramirez from Husco and in Waukesha. They are making huge investments in Industry 4.0. I'm pretty good friends with Todd Wanek, who is the CEO of Ashley Furniture Industries, largest furniture manufacturer in the world. He was on our podcast talking about his Industry 4.0 workforce. By the way, when I was in there 3 years ago, maybe 5 industrial robots. I was in there 3 weeks ago. They have 300 industrial robots in their plant in Arcadia, Wisconsin. The growth in their advanced technology, advanced manufacturing technology is astounding. Finally, and it's a little tough for me to read this, but I'm going to read it anyway. This is John Pfeiffer, President and CEO of Oshkosh Corporation, who I think we dropped that podcast about 3 weeks ago. He said, "We see things in the sense that everything has to be smart." And when I say everything has to be smart, it's everything has to be connected, has to be able to provide real-time data so that we can provide more value for our customer, or in the case of a manufacturing operation, the people that work in that operation. Oshkosh Corporation making huge investments in Industry 4.0 and advanced manufacturing technology. Now I'll say this, the big companies get this. The big companies are making these investments, and as we talk to the Blake Moretz of the world, as we talk to the Nick Pinchucks of the world, Rockwell and Snap-on respectively, these companies are making investments in Industry 4.0 technology. It's the 10 to 20 to $50 million companies that I'm worried about, because there's a freight train coming at them that is called Industry 4.0, and some of them are getting it, some of them are waking up to it, and a lot of them are not. And we have a job as evangelists for Industry 4.0 technology to explain to them the risk they run by not making these investments and not getting started. Number 3, I referenced him just a moment ago. Rockwell Automation is really, really quietly creating a whole portfolio of companies in the Industry 4.0 space. Now, I'm biased. I ran a Rockwell Automation spinoff for 10 years as CEO from 1998 to 2008. But some of the stuff that Rockwell is doing is fascinating. Blake was on the podcast as well. They bought a company called Emulate 3D. When we talked about digital twins before, that is a digital twinning company, and a big one. They put $1 billion into a company called PTC. This is all augmented reality, like looking through a HoloLens and seeing your schematic for whatever piece of equipment you're working on the shop floor, but looking at that through your HoloLens. Really, really cool stuff. They just bought an Industry 4.0 grade ERP system called Plex out of Troy, Michigan, acquired the whole company, I'm going to say about 2 months ago. So really, really quietly making some absolutely amazing investments in the world of Industry 4.0. Number 2 in how we are leading on Industry 4.0 technology is authentic industrial high school robot programs. And that is the fruits of that is what you're going to be seeing going on in that robotics competition right out here. We have more high schools in the state of Wisconsin teaching authentic industrial robotics than any other state in the country. Any other state in the country. We are producing more technicians than anywhere else in the country. My favorite story is a young man who graduated about a year and a half ago from Lomira High School. He took one semester, it would be a 3-credit course in technical college, 1 semester course in his high school in robot operation and programming. He started the day after graduation with a huge manufacturer in Washington County programming industrial robots, industrial paint robots. Now, I don't know what that kid makes, but that's a job that starts at $60,000 a year and can range to like 80 in your first year or so. Imagine graduating from high school, having taken one class, and getting a job right out of high school making $60,000 to $80,000. You can live in any apartment you want, you can drive any pickup truck you want, and guess what? His employer will pay him to continue his education. It is not the end of the road for this young man, it is just the beginning, and his opportunities are endless. Number one reason that Wisconsin is leading on Industry 4.0 technology is our huge interest among industrial employers. And I can tell you that in the last 18 months, and as you can imagine, I speak on this topic quite a bit, and I speak on it all over the Midwest and in some cases all over the country, these rooms are starting to fill up. We would speak at conferences like this with a title like Industry 4.0, and you'd have one guy sitting in the front seat, and you'd sit down and just have a conversation with him. We're starting to fill up. We're starting to understand the importance of Industry 4.0 training. We at our tech center in Mequon about 2 weeks ago advertised a free training program, 2 days on Industry 4.0 technology, did a deep dive on all the stuff that we're talking about today, and we filled the room with 20 different companies from southeastern Wisconsin of people that wanted to understand how this is going to transform their manufacturing operation. So that is my way of thanking the audience this morning for your interest in the topic, because it is people like you who are driving Wisconsin forward into the world of Infinity.0.